Imagine you just hired a profoundly gifted junior developer. Like, they work at the speed of light.
Right.
They have perfectly memorized every piece of API documentation ever written, and they literally never sleep.
Sounds like a dream hire, honestly.
It does. But on their very first day, you realize a terrifying flaw. If you aren't watching their every single keystroke, they might accidentally drop your production database.
Because they thought it was a local testing environment or something.
Exactly. The raw capability is staggering, but the need for management is absolute. And today, we are looking at the exact blueprint for how you manage that developer.
Yeah, we are dissecting a massive leap in human-computer interaction today. The document we're analyzing is the GitHub Copilot changelog from March 11, 2026.
Specifically for JetBrains IDEs, right?
Right, detailing these major agentic capabilities. And what we're witnessing here is it's basically the official death of AI as just a mere autocomplete engine.
The whole tab to finish a bracket era.
Exactly. The era of the machine passively waiting for you is over.
Okay, let's unpack this, because the very first major announcement in this document drops this huge conceptual bomb on the traditional workflow.
Oh, absolutely.
It says custom agents, sub-agents, and the plan agent are now officially in general availability, or GA.
Which is huge.
It is. To put that in perspective for you, it feels like we're upgrading Copilot from a fast typist who finishes our sentences to a junior developer who can actually plan out a multi-step project.
Yeah, from scratch.
Right. But how does that, actually manifest inside the IDE?
And what's fascinating here is the architectural shift from monolithic prompts to multi-agent orchestration.
Multi-agent orchestration.
Yeah. Historically, if you asked an AI to build a user authentication flow, it would just try to spit out a single massive wall of text.
Like the front end form, the back end logic, the database schema all at once.
Right, all shoved into one response.
Yeah.
And it inevitably hallucinated or just completely lost the thread. But now the AI mirrors a real engineering team. The newly GA plan agent acts as your lead architect. You give it that exact same prompt, and instead of writing code immediately, it analyzes your code base and drafts a sequential, multi-step execution plan.
So basically creates a checklist.
A highly intelligent checklist, yeah. And once you approve that plan, the plan agent delegates those individual steps to specialized sub-agents.
Wait, so there are multiple AI agents working at the same time?
Exactly. One sub-agent is temporarily spun up solely to handle, say, the React front-end components.
Oh, wow.
And another totally isolated sub-agent focuses strictly on the SQL migrations. By constraining each sub-agent to a really narrow context, the accuracy just skyrockets.
Because it's not trying to juggle everything.
Right. You are no longer crossing your fingers and hoping a massive text generation works. You are managing a synchronized team of digital workers directly inside your editor.
Okay, so we've handed these sub-agents the autonomy to make plans and execute them across the code base. But, that immediately creates a massive new anxiety for me. If I have 5 sub-agents running around my application, modifying files and executing terminal commands.
Yeah, you're terrified of what they might break.
Exactly. We need boundaries. How do we keep this autonomous team from, deleting a critical directory or pushing unvetted code to main?
Well, autonomy without rigid, verifiable boundaries is just a non-starter for any serious engineering team.
Right.
And the changelog addresses this directly by introducing agent hooks.
Agent hooks?
Yeah, which are currently in public preview. They're essentially tripwires and checkpoints that you code right into your repository.
Like in a config file?
Yes, you define them in a specific file called hooks.json, located inside a .github/hooks folder.
Okay, that makes sense.
And the system supports 4 specific lifecycle events. There's user prompt submitted, pre-tool use, post-tool use, and error occurred.
Let's focus on pre-tool use for a second, because that seems like the ultimate safety net.
It really is.
If an agent decides it needs to use a tool to delete a table, how does that hook actually intercept the command?
So when a sub-agent decides to invoke a tool, the Copilot engine literally pauses. It looks at your hooks.json file and triggers the script you've bound to that pre-tool use event.
Oh, so it hands the data over to your script.
Exactly, passing the tool's intended arguments. Your script can then evaluate the context. It can check an environment variable to ensure the targeted database is strictly local.
Or check if there's a code freeze.
Right. It can ping your internal deployment calendar. And if your script returns an error or rejection code, the subagent is physically blocked from executing the tool.
It just hits a wall.
Yeah, and it's forced to rethink its approach.
So the engineering team maintains absolute programmatic control over the AI's physical capability.
Exactly.
But that brings up another highly technical feature mentioned alongside these hooks. The changelog highlights auto-approve support for MCP.
Ah, yes. Model Context Protocol.
Right, at both the server and tool levels. And I have to push back here. Wait, isn't auto-approving an AI's tool usage incredibly risky? We just established that we want to control the AI.
I know. It sounds like a glaring security hole until you understand what MCP is and how it actually interacts with those hooks we just discussed.
Okay, explain MCP for me.
So Model Context Protocol, or MCP, is essentially a standardized universal plug adapter for AI. In the past, if you wanted an AI to read your GitHub issues, query your PostgreSQL database, and check your Slack messages.
You had to write custom API integrations for every single one.
Exactly. Fragile, annoying integrations. MCP creates a standard protocol so the AI can securely interface with any tool that supports the standard.
So it's like USB-C for artificial intelligence tools.
That is exactly the right mental model.
Yeah.
Like USB-C. Now imagine a subagent trying to debug a complex issue.
Okay.
It might need to read a log file, query the database, check the schema, and read another file. That is 4 distinct tool calls. If you do not have auto-approve turned on, a modal pop-up is going to hijack your screen 4 separate times, asking, "Are you sure you want Copilot to read this file?"
Oh, I see. The developer would just be clicking approve all day instead of actually working.
Precisely. The friction defeats the entire purpose of an autonomous agent. So the system design pairs the granular JetBrains level auto-approvals for MCP with the non-negotiable repository policies.
The ones enforced by hooks.json.
Right. You can safely go into your settings and tell Copilot, always auto-approve read-only MCP tool calls for this specific local server.
Which eliminates the annoyance of constant pop-ups.
Exactly. You have the peace of mind to let the AI run at full speed, knowing that if it tries to execute a destructive command, your pre-tool use hook will just slam on the brakes.
That is such an elegant solution, though the document does note a significant caveat for the enterprise crowd.
Yes, the administrative policies.
Right. If you are operating under a Copilot business or enterprise license, an individual developer cannot just start writing local hooks.
No, they can't.
The organization's admins must actively enable the editor preview features policy. So the IT department still holds the ultimate master key.
Which is a necessary reality for enterprise rollouts, honestly. They have to ensure compliance across the whole engineering floor.
Yeah, before any of this autonomous execution begins.
But, let's advance the scenario a bit. We have the plan agent breaking down tasks. We have the sub-agents executing them.
And the hooks keeping them from destroying the application.
Right. But a sub-agent that writes syntactically perfect code might still write code that your senior engineers absolutely hate.
Oh, for sure, because every code base has a culture.
Exactly.
There are weird naming conventions, preferred utility libraries, architectural patterns that aren't necessarily right or wrong, but they're just the way we do things here.
And if we connect this to the bigger picture, we hit the fundamental limitation of large language models up to this point, which is context amnesia.
Yes.
Historically, you'd start a new chat session with your AI, ask it to build a component, and it would use some deprecated CSS framework.
And you'd spend the first 10 minutes of every session correcting it, begging it to remember your project's specific conventions.
Exactly.
Well, here's where it gets really interesting, because the solution to that amnesia is buried in this changelog.
It is.
GitHub has introduced full support for instruction files, specifically AGENTS.md and CLAUDE.md.
Which is such a massive quality of life upgrade.
And you can even have these files nested deeply within different directories of your repository. Copilot will automatically discover them and load them into its context.
Yeah.
To me, this agents.md file is nothing less than an automated employee handbook.
The employee handbook analogy is perfect because it dictates behavior before the work even begins.
Yeah.
The moment you type the new /memory command or spin up an initial agents.md in a fresh chat session, you are codifying your engineering culture.
So I can write rules like always use our internal date formatter class instead of the native library.
Exactly. Or all database queries must include pagination.
And because it supports nested files, I assume you can have a global agents.md at the root of the repository for general rules.
And a highly specific agents.md sitting inside the front-end folder.
That strictly dictates React component structures.
That is the exact mechanism. When a sub-agent is working inside the front-end directory, Copilot merges the global instructions with the local directory instructions.
And just silently injects them into the system prompt?
Yes. You never have to repeat yourself. The AI boops up, reads the handbook for that specific zip code of the code base, and aligns its output with your team's culture.
That shifts the AI from a generic coding assistant into a bespoke, domain-aware colleague.
Completely.
Okay, so the AI knows the boundaries thanks to the hooks, and it knows our culture thanks to Agents.md. It's off making complex plans.
Right.
But that introduces a terrifying black box problem.
How so?
If I am handing over this much architectural responsibility to an LLM, I need to know how it is arriving at its conclusion.
Yes. Transparency.
Exactly. And this update fundamentally changes how we view the AI's internal thought process, starting with the announcement that auto model selection is now generally available.
This is a massive shift in user experience. Previously, developers would constantly toggle a drop-down menu, guessing which AI brain to use.
Like, is this a simple syntax error? Let me use a fast, lightweight model.
Right. Or, is this a complex architectural refactor? Let me switch to GPT-4 or Claude.
But now, Copilot just picks the model for you dynamically based on real-time availability and performance.
Yes, it auto-selects.
But wait, doesn't that take the control out of my hands? If the AI is auto-selecting the model on my behalf, don't I inherently lose visibility into the system?
Well, this raises an important question, and it highlights a brilliant design trade-off in the changelog. GitHub is indeed removing the manual steering wheel.
Okay.
Instead of you guessing, they're utilizing a lightweight router model behind the scenes.
A router model?
Yeah. The moment you submit a prompt, this router assesses the complexity of your request in milliseconds.
So it decides if it's a simple or hard task.
Exactly. It decides whether to route the request to a high-speed model for a quick regex fix, or a heavy-duty reasoning model for a massive refactor.
Got it.
You lose the manual toggle, yes. But to balance that loss of control, they were adding unprecedented transparency into the cognitive process of the model they selected.
So they take away the steering wheel, but they give me a glass dashboard to look straight into the engine.
A glass dashboard is a great way to describe the new dedicated thinking panel.
The thinking panel.
Right. When the router model hands a complex task over to an extended reasoning model, like OpenAI's Codex or Anthropic's Claude 3.7, the AI doesn't just immediately start generating final code.
What's it do?
It enters an internal monologue. It generates hypotheses, tests them against the context, realizes a flaw, and discards the bad idea before it ever streams a single character of code to your editor.
And previously, we just stared at a loading spinner for 20 seconds, hoping the final output wouldn't be garbage.
Exactly. Now, this thinking panel actually lets you read that internal monologue in real time.
You can watch it debate itself.
You really can. And crucially, they have added a new context window usage indicator directly in the chat panel alongside it.
What does that show?
As the AI is reasoning, you can visibly track how much of its short-term memory, its context window, is being consumed by the codebase files it's reading.
And the internal logic it's generating. That builds immense trust for me.
Oh, absolutely.
If a junior developer hands me a complex solution, I want to see their scratchpad. I want to know they considered the edge cases.
Right, you want to see the work.
But there is a phrase in the section of the changelog that completely blew my mind. It said, configurable anthropic thinking budgets.
Oh.
What exactly are we budgeting here? Dollars.
No, we are budgeting compute tokens. The term Anthropic refers to the creators of the Claude family of models, which heavily pioneered this visible reasoning architecture.
Okay, so thinking tokens.
Yes. When an AI thinks, it generates these thinking tokens that consume the context window and cost compute power.
I see.
A thinking budget allows you to explicitly constrain or expand how hard the AI is allowed to ponder a problem before it is forced to deliver an answer.
Wait, really? So if I have a really difficult race condition in my multi-threaded application, I can literally go into the settings and increase the thinking budget, basically telling the AI, take your time, burn a massive amount of tokens, and do not give me an answer until you have thought about this from every possible angle.
Yes. You are managing cognitive resources.
Yeah.
Conversely, if you just need a standard boilerplate component, you can lower the budget so the AI doesn't overthink it.
And waste context window space.
Exactly. You are no longer just managing code, you are managing the allocation of artificial cognitive effort.
That is wild. But as incredible as cognitive resource management sounds, a brilliant digital mind is entirely useless if the user interface rattles itself apart while you try to use it.
Very true.
Which brings us to the final section of our source document. It transitions away from the theoretical and into the daily grind, the practical quality of life updates.
The foundational architecture. Tightening the bolts on a high-performance engine, because a smart agent cannot function if its chassis is broken.
Exactly. We see UX improvements across the board here. The chat panel now automatically opens after you log in.
A nice little touch.
Yeah. GitHub Enterprise users get device code prioritization to smooth out authentication bottlenecks. They've rolled out better support for Windows ARM platforms and refined NES trigger timing.
Ah, the NES trigger timing. For those unfamiliar with the acronym, NES refers to the next edit suggestion.
Right, the ghost text.
Yeah, the predictive, inline ghost text that appears as you type. Refining that trigger timing means it won't pop up and interrupt your flow when you are clearly in the middle of typing a specific variable name.
But it will seamlessly appear the millisecond you pause to think about the next logical block.
Exactly. It's all about reducing cognitive friction for the human.
But the quality fixes are where the reality of AI development really shows its messy side, I think.
Oh, definitely.
Like, they improve stability when the AI is trying to read terminal output. Why was that even an issue?
Well, this is a perfect example of the gap between a theoretical LLM and an applied agent.
Okay.
If an autonomous agent runs a test suite in your terminal and it fails, the agent needs to read that terminal output to figure out why.
Makes sense.
But raw terminal output is often full of hidden ANSI color codes, weird formatting characters, and massive truncated stack traces.
Oh, right. It's not just clean text.
Exactly. A standard LLM tries to read that raw text, gets confused by the hidden formatting characters, and hallucinates a completely incorrect solution.
Or it just simply crashes the plugin.
Right, so stabilizing terminal reading is what actually unlocks the agent's ability to autonomously debug.
The fancy brain needs eyes that can actually read the screen.
Perfectly said.
They also resolved a bunch of UI glitches like file icons flickering or action buttons lingering indefinitely. But my absolute favorite line item is the bug fix for the replace string in file tool.
Oh, yeah, that one is telling.
Apparently, the AI was struggling to apply file updates correctly. So what does this all mean? To me, an AI struggling to replace a string of text is the perfect encapsulation of where we are in tech right now.
How so?
Well, we have subagents with configurable thinking budgets debating architectural patterns, but sometimes the artificial superintelligence just completely forgets how to safely overwrite a paragraph in a text document.
It is remarkably humbling, isn't it? Large language models are inherently probabilistic. They are terrible at exact character counting and rigid spatial awareness.
Right?
When an agent tries to rewrite a specific function block inside a massive 2,000-line file, it can easily miscalculate the boundaries of the text it is supposed to replace.
Like accidentally deleting a closing bracket.
Yes, and breaking the entire abstract syntax tree of the file. Fixing the replace string in file tool isn't just a minor patch. It is ensuring that when the AI decides to execute its brilliant plan, its hands don't slip on the keyboard.
It grounds all this high-level theory in the messy reality of file manipulation. And tucked right at the end of the changelog under a deprecation header is a note that edit mode has been officially deprecated from the chat mode dropdown.
Which serves as the perfect conclusion to this entire document, I think. Deprecating a dedicated edit mode brings us full circle to the very first point we discussed about agentic capabilities.
Wait, how does removing a feature prove the agentic shift?
Because a dedicated edit mode implies a localized, highly constrained, and isolated action.
Like a user highlighting a specific block of text, opening a prompt box, and asking the AI to change a variable name.
Exactly. It is a relic of the passive autocomplete era. The tool has evolved beyond isolated text edits.
I see.
When you have a plan agent drafting a roadmap, subagents executing terminal commands across multiple directories, and hooks validating every tool use against your company culture.
The concept of a siloed edit mode is totally obsolete.
Right. The AI is constantly evaluating, editing, and architecting the entire project contextually. The entire paradigm is edit mode now.
The entire paradigm is edit mode. That is a brilliant way to conceptualize the new normal.
It really is.
Let's recap the journey we've taken through this changelog today. We started by looking at the staggering shift from passive autocomplete to the general availability of proactive plan agents and specialized subagents.
We then explored the critical mechanisms of control, the intricate push and pull of using model context protocol auto-approvals to keep the AI moving fast.
while heavily enforcing your repository's security boundaries with programmable pre-tool use hooks.
Right.
We looked at how you teach this new autonomous team your specific engineering culture, utilizing nested Agents.md files as an automated employee handbook.
Whoa, to cure the AI's context amnesia. Yeah. And we unpack the intentional design trade-off regarding transparency.
Oh, the router model.
Yes. By utilizing a router model to auto-select the best AI, GitHub removed the manual steering wheel, but replaced it with the deep visibility of the new thinking panel and context window indicators.
Allowing you to watch the model debate itself in real time.
Exactly.
And finally, we grounded the theory in the foundational reality of the IDE, exploring why stabilizing terminal output reading and fixing file replacement bugs are the essential Titan bolts required to make autonomous debugging a reality.
It is truly incredible to see the mechanics of software engineering evolving this rapidly.
It is.
And as we conclude, I want you, the listener, to consider the deeper implications of a single concept we discussed today, the anthropic thinking budgets.
Oh, that was fascinating.
We are now at a point in human-computer interaction where a standard feature of your daily software tool is the ability to manually allocate cognitive resources to an artificial mind.
You are deciding how hard a machine is allowed to think.
Exactly.
Yeah.
It heavily suggests a fast-approaching reality where your primary value as a developer will no longer be writing the actual logic. You won't be the one typing out the loops, the API calls, or the database migrations.
Because the sub-agents are doing all of the typing.
Precisely. Instead, your daily job will evolve. You will become a cognitive resource manager.
A cognitive resource manager.
Yeah. Your days will be spent allocating token budgets, defining cultural guardrails in markdown files, writing security hooks to protect infrastructure, and directing the focus of a specialized digital engineering team. It is a complete evolution of what it means to build software.
That is an incredibly wild thought to carry into your next stand-up meeting. Well, that wraps up our deep dive into the March 11th GitHub Copilot changelog. Thank you so much for joining us.
It was a pleasure.
The source material explicitly encourages JetBrains users to update their plugin, try out these new agentic capabilities, and provide feedback on their repository. They are building this new dynamic workflow right now, and they want to know how it feels in the hands of actual engineers.
So get in there and try it out.
So the next time you open your editor, take a second and think about the vast difference between a blinking cursor waiting for your command and a dynamic colleague who is suddenly thinking, planning, and budgeting its own cognitive power right alongside you. We'll catch you next time.